So this is our inverse functions homework, or inverse of functions homework. So the first one is just to show that these two functions, f of x and g of x, are inverse functions of them algebraically and graphically. So remember, the algebraic way is just to do f of g of x and g of f of x, and they should equal x. So f of g of x, so for x we put in g of x, and you can see that the 2's cancel out, we get x, and g of f of x is equal to, so we substitute f of x in for x, so you get 2x divided by 2, which simplifies down to x. So since f of g of x equals x and g of f of x equals x, now from a inverse function, the linear ones are reasonably easy to do. The ones that are not linear are a little more difficult if we don't use some kind of graphing program. So we'll probably use a graphing program for those, but let's do the linear ones. See how that works out. So we got 2x, which is a diagonal line with a slope of 2 that goes through the origin. So that's what that looks like. And if we extend it, we get that. Okay, so that's f of x equals 2x. Now the f of x equals x over 2. It still goes through the origin, but it has a slope of a half, which means it's going to look like that. And then we can extend that to the other side like that. And remember, the third thing we do is a diagonal line, y equals x, and those two should be symmetric around that line, which they are. So that's how you prove that graphically. Okay, number 2, same thing, f of g of x. So f of x is 7x plus 1, so you have 7 of x, 7x plus 1, but instead of putting x, we put in x minus 1 over 7. So you see the 7's cancel out. That gives you x minus 1 plus 1, which is x. And then g of f of x. So g of x is x minus 1 divided by 7. But for x, we put in 7x plus 1. So you can see this cancels out with that, so we're left with 7x over 7, which is x. So that's algebraically. Let's do it graphically. Get a piece of graph paper. So these are not quite as simple a graphs, but so f of x was 7x plus 1. So it has a y-intercept of 1 and a slope of 7. So I guess it looks like that. So what it is over up 7, 1, 2, 3, 4, 5, 6, 7 over 1. And you can go the other direction. So down 7 over 1. So let's do that. So make sure I'm doing this right. So over up 7, 1, 2, 3, 4, 5, 6, 7 over 1. Down 7, 1, 2, 3, 4, 5, 6, 7 over 1. So it still needs to go a little bit this way. So there we go. Okay, so that's that one. The other one was x minus 1 over 7. So So g of x was equal to x minus 1 over 7, which is the same as 1/7 x minus 1/7. So that's going to have a intercept of negative 1/7, which is going to be right there, and a slope of 1/7. So let's draw that. So we're going to start 1/7 slope of this is where it gets a little tricky. So we go over 1, 2, 3, 4, 5, 6, 7. Is that 7? 7 up 1. So it's going to go to about right there. And it's actually minus 1/7, so it goes a little below like that. So minus 1/7 slope of 7. So this thing needs to come down a little bit. Actually, let's start over again. So this goes down here, negative 1/7. This needs to come down to there. Okay. And then we stretch this thing out like that. And then if we do the diagonal line here, something like that. So again, you can see that it's symmetric around that line. Okay, then the next two are, the next three, we're going to use the graphing function that you can get access to. So if you can plot it out on your graphing calculator, use the graphing program. And one thing you got to do is make sure that this thing is, so these squares are actual squares. So I'm going to just do this kind of eyeball. I want to make sure these are approximately squares and not rectangles. So the next function is x cubed over 8. So we have x cubed divided by 8. And the second function is, well, I got to do that analytically, but let's do it. And 8x to the 1/3 power. So that's rewriting it as a fractional exponent instead of as a cube root. And if I graph those two, and I also graph y equals x, you can see how these two functions are symmetric. Okay, so that's graphically. Analytically, for number 3, we have f of g of x. So we have f of x is x cubed divided by 8. But for x, we put in the cube root of 8x. So when you take the cube root, cube something of the cube root, you just end up with what's inside. So you get 8x over 8, which is equal to x. And then you have g of f of x. So g of x is equal to the cube root of 8x. But for x, we stick in x cubed over 8. So these cancel out. And the cube root of x cubed is x. So that's doing it analytically. We've already done it graphically, so we can move on to the next problem. So we have f of g of x is the square root of x minus 4, but x is going to be g of x, so that's x squared plus 4. So these cancel out. You get the square root of x squared, which is x. And then you have g of f of x go the other way. So we have x squared plus 4. For x, we put in the square root of x minus 4. So the square root of x minus 4 squared is x minus 4. We add 4, and we get x. So f of g of x equals x, and g of f of x equals x. So let's do that graphically. Now what we'll find out is that the this domain is for x greater than 4, whereas this domain is all real numbers. So it's an inverse function with a limited. The domain is somewhat limited. So let's so we're going to do f of x equals square root of 4 minus x, and the other function is x squared plus 4. X squared plus 4. Graph those. And so let's zoom out a little bit here. So this part we ignore. So we're just going to take positive x, and you can see how this is symmetric with that across that. I'm just going to resize that a little bit. Okay, the final one of this group. And here we said x has to be less than or equal to 9. Here x had to be greater than or equal to 4 for this to work out. This function, the domain. Here we let x was greater than 0 so that these matched up. Okay, so we'll do 5 analytically first. So we've got f of g of x. So we have 9 minus x squared. For x squared, we put in the square root of 9 minus x. So the square root of 9 minus x squared is just 9 minus x. So this cancels out with that. And then we have a minus, so that becomes plus. So it's plus x. And then we have g of f of x. So we take the square root of 9 minus x, but for x we put in 9 minus x squared. So these cancel out again, and so we get the square root of, usually have a negative times a negative, so it's positive square root of x squared, which is x. So that's analytically, and then graphically the functions are as such. So you've got 9 minus x squared and the square root of 9 minus x. 9 minus x. Graph that. Okay, so that looks a little crazy, but let me zoom out a little bit. So you can see that x has to be less than 9. So I can't really mark through it. I can take a picture of that and put it on my screen. So let me get the camera. So we'll just do that and take a snapshot. And we'll stretch that thing out a little bit. Okay. So what we need to do is we need to ignore part of this. So I'm going to mark through the part that, so we don't need to look at that part right there. It's just making things crazy. So here are the two symmetric parts. So you got this part and you've got that part. And you can see how they're symmetric across the axis, and then these would go this way. And then that would go like that. So they are symmetric. We just don't do that part of the curve. Okay, so that's those. Oh, we got another one here. So let's add a page. Yeah, these are, this is 6. So f of g of x. So we're going to have x minus 1 over x plus 5. But instead of putting x in there, we put negative 5x plus 1 over x minus 1. Negative 5x plus 1 over x minus 1. Don't worry, I'm not going to put this one on the test, but I'm just going to show you how it works. So what you do is you find a common denominator in both the numerator and the denominator. So you're going to multiply, if you multiply the top by x minus 1 and the bottom by x minus 1, what will happen is you will get negative, so I'm going to put the negative sign with these, negative 5x plus 1 over, it'll be over x minus 1, and then this one will be negative x minus 1. So you take this times that, you get that, all divided by x minus 1. So that's combining these two terms into a common denominator. So we don't multiply this by anything, we multiply the numerator and the denominator by x minus 1. So you get that, and you can do the same thing in the bottom. So we're going to multiply by x minus 1 again. So you'll get negative 5x plus 1 plus 5 times x minus 1, all divided by x minus 1. Okay, that cancels out with that. So in the numerator we have, let's distribute everything out here, negative 5x minus 1 minus x, and you have a minus times a minus, so that's plus. And then the denominator we have negative 5x minus 1 plus 5x minus 5. So in the numerator, this cancels out with that, and you get negative 5x minus x, which is negative 6x. And the denominator, these cancel out, and you end up with negative 1 minus 5, which is negative 6. And those cancel out, and those cancel out, and you're left with x. So, believe it or not, that worked. The second one, so that was just f of g of x. Now we do g of f of x. So you have g of f of x. So we get negative 5 times x plus 1 divided by x minus 1. But for x, we stick in x minus 1 over x minus 5, x minus 1 over x minus 5. So again, I'm going to create a common denominator. So I'm going to multiply this by x minus 5. And this by x minus 5. Actually, what we're really doing is multiplying by, we're multiplying this term, just the last term, by x minus 5 over x minus 5. And same way over here, we're going to multiply this by x minus 5 over x minus 5. So I'm multiplying both of those by 1. So we'll go back and look at the first one and correct that. So what you'll end up with in the numerator is negative 5 times x minus 1, and you'll have plus 1 times x minus 5, all divided by x minus 5, and then the denominator, you're going to end up with x minus 1 over x, well, put it all here. So we get x minus 1 minus x minus 5 divided by x minus 5. So these combine together. You see those cancel out. So in the numerator I have, and I'm going to distribute these things out, so we get negative 5x plus 5, negative 5x plus 5, plus x minus 5, all divided by x minus 1 minus x plus 5. So this negative makes that minus, this negative makes that plus. And you can see that this cancels out. Well, no, that's not true. It's the other one. This cancels out with that, and this cancels out with that. And what you're left with in the numerator is negative 4x, 5x plus x, and then the denominator you're left with 5 minus 1, which is negative 4. Well, it's actually positive 4, so what did I do wrong here? Because I'm going to end up with negative x, so I must have done something wrong. So let's go back and look at this. Okay. Negative 5 times x plus, wow, there. So this should be minus, because this minus sign is applied to both terms. So that's going to be minus. So that'll be minus. So I'm still having a problem. Oh, that should be plus. That should be plus. That should be plus. So multiplying by plus. So that's going to be plus. That's going to be plus. Down here, that's going to be plus. Sorry about that. Just shows you got to. What happened there was, I got to a point where I didn't get the right answer, so I had to go back and figure it out. Hopefully, this is plus here. So let's see if that works. So you get negative 5x plus 5 minus x minus 5 divided by x minus 1 minus x minus 5. Okay, so this cancels out with that. This cancels out with that. So I have negative 6x in the numerator, negative 6 in the denominator. That comes out to be x. So let's go back to this first one and see where I made a mistake. Okay, yeah. So what I did here was I multiplied. What I really did was I took this term multiplied by x minus 1 over x minus 1, and I took this term, did the same thing, x minus 1 over x minus 1, but not this one. So that gave me a common denominator of x minus 1. Okay, so that's what needed to be corrected there. Okay, let's plot these things. So this should be exciting. So the first function is going to be x minus 1 divided by x minus 5. And the second function is negative 5x plus 1, negative 5x plus 1 divided by x minus 1, and we graph those two, and we get that. So, let me double check that. That looks a little wild. X minus 1 over x, oh, there we go, plus 5. That'll help. And the second function is negative 5x plus 1 over x minus 1. So that one looks right. Okay, yeah, that looks a lot better. So you can see how these are symmetric. You see how that part's symmetric. I hate to have to plot that by myself. Okay, the next problems are finding the inverse function given the function. So we've got 7. So the way it works is you have f of x is 3x plus 1. For f of x, you put in y, like that. And then you switch. So y becomes x, and x becomes y. And then you solve for y. So what we do is we'd subtract 1 from both sides, divide both sides by 3, switch the left and the right hand sides. And then for y, you put in this f prime of x. So that's going to stand for the inverse. So the inverse function is x minus 1 over 3. Okay, so that's the first problem. Number 8, f of x equals x cubed plus 1. So we're going to say y equals x cubed plus 1. Switch, y becomes x becomes y. Solve for y, so subtract 1 from both sides. Let's go ahead and switch them now before we... And then you'll take the cube root. So the cube root of x cubed is that, and the cube root of that is that. Now I'm going to come back and and plot these things, but we're going to go through the process of finding the inverse functions first. Okay, so this is 9. F of x equals x squared. Y equals x squared. Switch. Flip these on either side. Take the square root. We're going to use the plus the square root of x, because if we take plus or minus the square root, we'd have both of them, but we're only going to deal with x greater than 0, so that's why we're going to do the plus square root. And then so you can say f prime, the inverse function is plus the square root of x. Okay, do 10. So f of x equals x squared minus 2. Y equals x squared minus 2. Switch. Y becomes x. X becomes y. Add 2 to both sides. Switch the two sides. Take the square root, so you get y is equal to plus or minus the square root of x plus 2. We're going to take the positive square root. We have to choose one or the other. So we got 2 more problems, but let's go ahead and graph what we have so far. So we're going to go back to 7, and we're going to plot those functions. So you've got 3x plus 1 and x minus 1 divided by 3. Let's double check that. 3x plus 1, x minus 1 over 3. Graph those, and there you go. So you can see how they're symmetric across this line. Next problem, number 8. So we have the function x cubed plus 1, and we have the cube root, so we're going to show that as x minus 1 to the 1/3 power. You can put the 1/3 in parentheses. So there it is. Interesting looking function. So that works out good. Notice that none of these had limitations on the domain. These next two do, so let's see how that differs. So move this over here. So my original function is x squared, and my inverse is equal to the square root of x. So there you go. So what we're doing is we are ignoring this part of the y equals x squared curve, because you can see these two are symmetric, but this one is not applicable. And then we have the next one, which is going to be x squared minus 2 and the square root of x plus 2. So that's it. So again, we would ignore this part of the curve. So this would match up with that. That goes there. So these are the symmetric parts of the curve. And you can see why, originally they wanted x to be greater than 0, I think here. X is less than 0. So let's look at the graph. Oh, gotta look at it here. So x is less than 0. So maybe we should have done negative the square root instead. Okay, the last two problems, here they are. So analytically, you've got f of x equals negative 2 over x. So y equals negative 2 over x. Switch x and y out. Solve for y, so we could switch these two. So you get y is equal to negative 2 over x. So it looks like the same function, and that's because if you plot negative 2 over x, negative 2 divided by x, you get that, and you can see how these parts of the curve are symmetric around the two parts. The x greater than 0, x less than 0 are symmetric around that. And then finally, number 12 should be interesting. So we're going to say f of x equals x minus 3 over x plus 2. Substitute y for x. Like that. Switch x and y. So how do we solve for y? Well, we'll create these two ratios and cross multiply. So you'll have x times y plus 2 is equal to 1 times 3 minus y minus 3. Then we'll multiply everything out. And we're trying to solve for y. So move all the stuff that involves y to one side. So this y moves to the other side, becomes negative. The 2x moves to the other side, becomes negative 2. Then you factor out the y, so you get y times x minus 1 is equal to negative 2x minus 3. Divide both sides by x minus 1, so I'm going to put the negative sign out in front here. So if I factor out a negative sign, I'll get negative the quantity x plus 3 divided by x minus 1. And then we call this f prime of x. F, the inverse function. It's negative 2x plus 3 quantity divided by x minus 1. So let's Let's go back up here. Here's my original function. So you got x minus 3 divided by x plus 2, and the second function, which is the inverse, is going to be negative, the quantity. 2x plus 3, close parenthesis, divided by x minus 1, close parenthesis, and we graph that, and there you see it. So the blue and the red curve here are symmetric around the y equals x, and these two are symmetric around it. So what you have is you have a reciprocal function that looks like this, and then you have another reciprocal function that looks like that, and you can see how they're symmetric around the line y equals x. So that's it.